Hi everyone, and warm welcome to the School of Mechanical and Aerospace Engineering talk. Today with us, we have Prof. Hortense. Before we start our presentation, we're going to wait another 2 more minutes. At 3 o'clock, we will start our presentation. So in the meantime, for those of you who are already here, feel free to make yourself comfortable as we wait for 3 p.m. Thank you. All right, everyone, thank you so much for joining us today. So once again, I would like to welcome Prof. Hortense, who has joined us to do her sharing on the Mechanical and Aerospace Engineering program. So Prof. Hortense, over to you. Prof. Hortense, please.
Okay, thank you, Eileen, for the introduction. Welcome, everybody. I hope you're well installed, and it's really great that you can take some time today on this Saturday to hear more about the School of Mechanical Aerospace Engineering. So I will give you an overview of what is mechanical engineering and then what is in the curriculum, so that we might address some of the questions you might have, and hopefully you will get excited and want to join us. So, so we call ourselves the School of MAE for Mechanical and Aerospace Engineering. So when I talk about MAE, I'm talking about us, Mechanical and Aerospace Engineering. So again, I want to address what are students going to learn at MAE, what should you expect when you join MAE, and what kind of job and careers MAE is good to be trained in for. So just before I go in, I'd like to share just who I am to give you a short idea. So, so here it's me with a different haircut. I am French originally. I studied in France, then I went to Switzerland, then I went to the UK, London, and I joined MAE as an assistant professor in January 2019. Okay, so before I joined MAE, and so I did my studies in Europe, I also worked a little bit in the USA and in Singapore. And I was really excited about Singapore, and then I wanted to stay, and I had the opportunity to join the School of MAE at NTU. So at MAE, I teach courses that are related to materials and manufacture, such as fundamentals of material science and engineering, which is in year 1, manufacturing processes in year 2, net shape manufacturing in year 4. I also supervise, as many of my colleagues, engineering, innovation, and design projects, which students take when they are in year 2 or 3, and final year projects that students take when they are in their final year, so in year 4. And usually these two kinds of projects students are really excited about, because it's really the moment when a student can really apply their skills and work on problem solving, as well as really doing research and development of new technologies. I also have a research group with PhD student, postdoctoral student, and researcher, and I like to focus on 3D printing, composite, ceramics, manufacturing, and testing. So here you can see pictures that are actually taken in our lab, where our students can be doing modeling on computers. They can be designing new devices and robots, or doing also some chemistry or biology as well. So with this, I'd like to invite you to start your amazing journey with us. So in the school, we have a very important belief, which is that by providing strong fundamentals and strong engineering foundation, you are getting industry relevant. So our curriculum is industry relevant and up to date. And with this, you will be able to apply and implement your knowledge into products and services through innovation. So what engineers do, engineers devise solutions to problems in a clever and creative manner. They are the link between scientific discoveries and the applications of these new ideas to the world. The value of engineering is therefore the creation of a better world, which I believe everybody wants. So if I summarize this from my perspective and in very short keywords, I would say that engineers, they solve problems and we need them to address global challenges. Example of these challenges are, well, currently this COVID pandemic. We know that engineers are devising amazing tools to help us work in this new environment and solve this problem. There is global warming and pollution. You are well aware of this. And already in Singapore, we have many innovation to help us solve this global warming and pollution. And another global challenging can be aging population, and I'm sure you can think of many other global challenges that we have to face. So for all of these challenges, we need engineers to provide us with solutions. Mechanical engineering as well, it's one of the oldest branches of engineering. So people have been inventing and building increasingly more sophisticated devices and machines in order to improve the condition of life. Many of these machines we encounter every day were made possible by mechanical engineers, right? Like right now you're watching on a computer screen. This can only be working now if we had engineers fabricating the screen and making them even more advanced every year, right? Every year we have more advanced skills. And here I'd like also to show you how old engineering is, mechanical engineering is. I think one of the first could be Leonardo da Vinci. You heard of him, right? He was designing, for example, those kind of aircrafts. And although these look very different from our airlines nowadays, it has been a very long thought process to go from these ideas, prototypes that were not really working to the aircraft that we have now today. So here in Singapore, engineering is really important. And this was highlighted by Mr. Teo Chin Han, the Senior Minister and Coordinating Minister for National Security, right? He said that engineering is vital to Singapore as it enters the next phase of development in 2019. And so speaking at the launch of the exhibition on engineering at the Science Center, Mr. Teo also encouraged more young people to pursue a career as an engineer or a scientist. So if you look at the figures from the Ministry of Manpower, so in 2017, I mean, it's a few years back, but it's still very valid today. Civil engineers, industrial and production engineers, mechanical engineers were occupations with the most job vacancies in the professional categories. So in short, there are job opportunities for engineers, and we need engineers, especially here in Singapore. So here is an example where really engineering is interesting. So this was shown in an article published in the Straits Times in 2020. where Mr. Chen Wei-Kyung, the director at the Robotics Automation and Unmanned System Center of Expertise under the Home Team Science and Technology Agency, developed the home-ground automated passenger in-car clearance system, which is called APIX. So APIX is a unique system that uses advanced robotics and sensor systems to perform immigration clearance for cars. And this allows quicker and more streamlined vehicle clearance through checkpoints. So this is a beautiful example where engineers working in robotics, automation can solve a problem and make our life easier by facilitating the streamline of vehicles at the checkpoints. Also, if you fancy yourself as a problem solver, then engineering may be for you. So in fact, there is no better time to enter this field. And this was highlighted by Prime Minister Lee Hsien-loong at the launch of this Home Team Science and Technology Advanced at Mediapolis in One North last year. So again, engineering is really how to solve problems, especially for making our life better or to advance the society in general. So in short, why should you use mechanical and aerospace engineering for your studies? So first, I summarize my points here. We need engineers because they solve problems. And by this, I mean any problem. So when we think of an engineer, we don't think only about problems in robotics or construction, right? We think really as a person who has developed the sort of process to solve a problem. And I know by experience, because most of my friends who also studied engineering, they end up also working in banks, in insurance companies, in management, in patenting, because they have developed the tools to develop problem-solving skills to apply to many different types of settings. So as an engineer, you can solve problems. We have problems everywhere. So we will always need engineers to help us solve these problems, whatever the field is. Also, again, an engineer is a person that knows how to learn new knowledge and that is adaptable to the settings, right? An engineer can fit in all industry. And this is also something that we called lifelong learning. So especially in these broad fields, in today's context where the amount of knowledge is getting huge, and we have faster accessibility through internet. So basically we cannot learn everything, but we can learn how to learn. And this is what we teach at MAE. So how to gain this knowledge and then being able to adapt and to acquire new skills depending on the problem, depending on the job. And finally, we are surrounded by objects, devices, and mechanic structures, design. They are absolutely key for all these objects and machines, devices to perform well. And this is one key aspect that MAE provides in comparison to other engineering fields. And therefore, these machines, devices, materials, mechanics, they are used also in very different types of application. It can be an apparatus in a hospital, it can be a building, it can be a train, it can be a robot, it can be a computer, you name it, which means that what you learn at the School of MAE, Mechanical and Aerospace, it's actually beyond the strict field of mechanical and aerospace, but available and applicable to a large range of applications. So these were my view of what engineers are at MAE. Now, what will Singapore be in the near future, right? Because you are learning now, you are choosing the future path for your learning journey to prepare yourself better for the future. And so here is a report that was published on Today Online on 30 March 2021 that highlighted that engineers, product managements were very much sought after by Singapore and regional tech firms among all the talent that are already in Singapore. So in this context, actually, today's there is a talent shortage in the technology sectors, and workers who take up such role in Singapore are paid much higher than their Southern Asian counterparts. Okay, so that's what this report found. So you may keep in mind when you choose your future career and what you should learn to prepare for it, that some sectors like technology, engineering, there may be more job opportunities in the future. And so this is my point of view because I'm a foreigner here. And I'd like to highlight that Singapore, it may seem, like a small country, while in comparison to a much larger country like China or the US. But actually, despite being small, it's very good for Singapore to have very good talents, and actually Singapore makes often a world impact. So here are just headline that I taken from French newspaper because I'm French. So of course, maybe you cannot read what is said, but you can recognize the pictures, and we see often Singapore as a model for teaching students. We see Singapore as the model for designing a new structure, also greener structures, such as these architectures that we found in Singapore, and also for driving new technical revolution. So this is, so the title says that Singapore is very ambitious to develop new autonomous vehicles, right, that we are starting to see today. So, and all of this, or most of this, they are also areas where students at NTU MAE, they are already in contact with through the different projects that they make, and also because they are in direct contact with professors like myself and my colleagues, who are our daily occupations also are researching in these areas. So if you're like me, you would find this pretty exciting. Now, more specifically, what students do at MAE, so they also innovate a lot, and this is a team from MAE students that won the Shell Eco Marathon in Asia in 2018, and they developed this very fancy car that has a specific design, and they made it using 3D printing. So here it's a combination of mechanical engineering and also a lot about design. We very much value experimental learning, and we have new innovative approach for hands-on machining, where the idea is to provide the student with practical experience in machining, and this will be for the entire cohort of MAE students in their second year. So the idea is that one student will be trained on one machine tool, and this would be for a total of 6 hours. And with this, the student, they can learn hands-on practice in machining, features of machining tools, and they will learn how to perform various types of machining processes, such as milling, turning, drilling, tapping, and also getting also some introduction of robotic applications for finishing operations. And the idea with doing this is so that the students are able to operate and perform machining tasks independently. And this kind of learning is assessed using a portal that is entirely online that we call NTU Learn, where we will ask direct questions for students that they will then answer, and then we can be able to assess how much the student has learned. So from the point of view of the students, or of you hopefully, it's quite exciting because it's like hands-on practice, right? So you actually acquire a new skill, but it also develops your thought process, because usually when you do this kind of task, you're thinking also like, oh, why is this difficult? How can I improve? Or maybe I could do a drilling a bit differently. Maybe it would be nice if the machine would be better. So not only you develop these skills, but it also develop more on your critical thinking possibilities, which is also very interesting. So this is, okay, so these are the cars that are running for the EcoShell Marathon I was showing earlier. And so the students were able to design such cars because they had some skill already on machining, as I was highlighting just earlier. So also acquiring these cars, these skills, you are able to now address real challenges. And when you do these kind of projects, real life projects, you have the skills to actually solve the problems and to develop prototypes. Also, in our hands-on culture, we are very lucky at NTU because we have 5 makers lab that are fully accessible to NTU students. And so they are opportunities for students to form interdisciplinary teams with other schools at NTU. And at NAE, what we like to focus on is on 3D printing. So here are some 3D printers that the student, they can get to learn and to access when they need to. So this also gives a lot more industry exposure, because our maker labs are, for example, with Dyson or HP, and we have engineers and researchers from these 2 industry who are in these labs, and they are usually also very enthusiastic to show to students how their machine works and what they can do. And so we also have actually partner research labs. So the professor and your future lecturers, they may also work in this lab and collaborate with the engineers from this industry. So from your perspective, it's really cool, because if you think, oh, maybe I would like to do an internship there or have a project there so that maybe in the future I can be hired as well by this company, then I mean, this is really a great opportunity. Also, we like to give students early research exposure. So we call it Eureka Projects for undergraduate research experience on campus. And this is for students in 2nd and 3rd year. And basically, they get to choose from 800 different research projects, which can be also multidisciplinary, so across schools. And basically, they just go to the research labs and then they carry out a research project of their interest, which is a really good opportunity as well to get a research experience in a different maybe a different field or in a topic that is completely new. And there is a chance also to be conferred a title of the NTU President Research Scholar if you really do well in this research project. And at the end of these projects, the student, they present their findings in a poster. I mean, here in this case, that was in person or in an online event as well. So a little bit more details about the curriculum. So what do we offer at NAE? So for mechanical engineering, we also have some shared or refined majors. For example, mechanical engineering and economics. mechanical engineering with a minor in business, mechanical engineering with second major in business, and mechanical engineering with second major in society and urban systems. So as you see, we like to think of a mechanical engineer as someone who is developing something for the society, for solving a problem, which is why mechanical engineers do not only need to have the technical skills, which you will get for sure, but also it's good to have like more ideas about leadership, business, society in general, which is what this kind of curricula provides. So there are three different tracks that can be taken at MAE. So there is one that is mainstream up to year 4. From year 2, it's possible to choose a specialization in design or a specialization in mechatronics. So mechatronics, if you're not familiar with this, is about how to develop like machines, like automations, this kind of technical skills. So about the mainstream, what is taught in the mainstreams are fundamentals of mechanical and engineering. So here are examples of modules: thermodynamics, heat transfer, fluid dynamics, engineering design. And then in year 4, it's possible to choose major prescribed electives. So in general, the topics in this fundamental and mechanical engineering are aeronautical engineering, systems engineering, manufacturing engineering, naval architecture and marine engineering, and smart manufacturing and digital factory. So for example, I was telling you in the first slides, I'm teaching topics that are related to net shape manufacturing processes and fundamentals of materials, which fit in this curriculum. So how to fabricate a cup, how to make a specific shape out of a metal that is also very strong and very tough. So these kind of topics are taught in this fundamental of mechanical engineering. So here I'm going to show you a very short video about 3D printing, which is one of the key topics that we are very excited at mechanical engineering. Sorry. All right, so what you've just seen is the 3D printing of concrete to make a bathroom that is cheap, that can be built anywhere, and that was done using 3D printing. And so this was developed by my colleagues at NTU, where students from mechanical engineering contributed as well in this project. And basically, we teach one of the lecture or one of the topic that we are very excited to teach to students could be how to fabricate such a innovative solution for cheap bathroom units. Now, let me move forward to the other streams. So the other stream I was talking about is the design stream, which can be chosen from year 2. So the design stream is also very interesting. It's multidisciplinary with a partnership with the School of Arts, Design and Media at NTU. And in this stream, there is an emphasis on creativity, technology, and design methodology. And it is aimed at training design professionals competent in engineering. So here are some examples of designs. So this is a specific new and innovative bracelet with a lot of functions incorporated into it. So I will also share a little bit details with the video in a short while. But basically what the students get to learn by developing such a tool is how to identify a problem, how to develop a concept, and then how to prototype it and to learn how to fabricate it, as well as inducing programming and the electronics that are playing a key role in its application. So here the problem was, for example, if you cannot, if you have difficulties to reading, can you like read but without without the vision? So using a tactile method. There is also the problem of having possibility to increase the privacy of communication. And then when you look at your smartphone, it's, I mean, current devices are quite bulky, right? So, and they're getting more and more bigger and not always very portable. So here were 3 of the problems that were highlighted. Oops. And so for the concept, maybe I'm gonna play. Oops, I just want to start again. Okay, well, so basically the idea is to get the reading through the fingers, through this button, and then to have a press and push sliding mechanism to operate the device. And then inside we have everything connected together. So basically it's a layer top-down assembly. It's easy to service and maintain because you just open it, and it has a very nice ergonomic design so that it can fit easily on the hand. So what you see is the solution, right? Now it's operated just by tapping with the fingers. And it's so you can appreciate the ergonomics. It fits very nicely in the hands, and then it's wired, or it's communicates to the smartphone interface so that it can really translate what the person was typing just with these keys without having needing to see a screen, but then it was translating it into words so that it can also just speak to someone. So if you have if you are vision impaired, or even if you are in a black room, I don't know, like in a cave, right? We had some incidents, right, in the news, people stuck in caves. So that could be a tool, right? Easy to communicate without the need of seeing. Very small, you can carry it with you all the time. So this is just an example of what you would get to learn to do, or you would be able to do following the design stream. Finally, the last stream is about robotics and mechatronics. So how to design such kind of robots. So this stream is exciting because it's also multidisciplinary. So it's getting to learn mechanical engineering with electronics, computer, and intelligent control. So here is a team of students where they fabricated a robot. So I'm toward the end of my presentation, and I would like to summarize the key point that I think makes it exciting to join MAE. So not only you will get to learn about design, robotics, engineering, mechatronics, but you will also learn how to learn. You will have the opportunity from hands-on industrial relevant experience, and your skills will be transferable to other disciplines. So mechanical and engineering employers are from many different fields. So here you can see a pool of very famous names of very famous companies that employ mechanical and aerospace engineers. And these go from Philips to Singapore Post, Singtel, Rolls-Royce, Starhub, Procter & Gamble, HP, Schlumberger. So really, there is really a large job opportunities for mechanical and aerospace engineers. Finally, also the after graduating from NTU MAE, mechanical engineering mean gross salary is about 4,000 Singapore dollars. So this was from MOE NTU Graduate Employment Survey in 2020. It has not changed much. So it's really good career prospects. So you can also think about that. So I think with this, thank you again for joining me today to share you more about this. And I hope really to see you soon at the School of MAE at NTU. So now I will give back the screen to my colleagues here.
Thank you, Prof. Hortens. I'd like to, Ziwei. I would like to hand the time over to Ziwei to actually do a little bit of sharing on the club before we go into Q&A. So I have seen a lot of questions coming in, both on Slido and on Zoom. Just keep them coming in and we'll get to them very shortly. Ziwei, over to you.
Okay, Lynn. So, hi everyone. I'm Ziwei. I'm from the MAE Leadership Development Program, which is one of the clubs we have here in MAE. So I'm been invited to share a little bit about what we do and more about clubs and school life in general. So let's go on. So first, let's talk about who are we. So we are called the Leadership Development Program, but what does that actually mean? So we are a student organization in MAE, like I said, and our focus is on the leadership development of students. So now that sounds a bit ambiguous. You're not quite sure what it is, but what we actually do is do events planning. So we feel that by training students on events planning, it allows them to develop leadership in various ways, especially in their soft skills. So a few of the skills that we pick up are like coordination with external parties, so learning how to communicate with external parties, whether it be other clubs, whether it be external companies or external welfare organizations. We have done a lot of workshops and activities with them. Another one would be logistics planning and budgeting. So this is important when you're planning the event. Of course, you need to know how much money you're spending, what items you may need to run the event smoothly. Also, professional writing, because for planning an event, it involves a lot of writing for communication with external parties, but not only that, you also have to write formal proposals and reports post-event. And finally, contingency planning, because as we engineers like to say, Murphy's Law exists. So when things happen and you don't have a contingency, that's bad. And when we're running events, we always have contingencies planned to be able to deal with any unexpected circumstances. And this is just a few. These are just a few of the skills that we train our members on, mostly by getting them to actually run the event. Now let's go into a bit more about what we actually do. So firstly, we have our STEM workshops for children and disadvantaged groups. So this has been our flagship events since, especially since COVID hit. Previously, we had a variety of others, but with COVID as it is now, this is what we are focusing on. On top of that, we have talks and workshops for students in NTU. And on top of that, also other events that I'll get talk more about later on. And also internally, we have programs to develop our members. So the mentor-mentee program is something that we have for our members where we get new members to run a workshop or event entirely on their own while supervised by one of the more experienced members as a mentor. So this gets them lets them get their feet wet, but also lets them actually have the full experience of running said event. Now let's go into a little bit of like pictures because I talk a lot and it's kind of hard to imagine. So our STEM workshops, these were from a 3D printing workshop we actually ran with TJYN, the Taman Jurong Youth Network. So this was for their kids, and they were around, I would say 11 to maybe 13. And so it was just an event for them to like experience the 3D printing pens, which I think you can see just over here. And also to expose them a bit to 3D printing and what it is so that we can, build the interest in STEM early on in their life. We also have robotics workshop. So this was a workshop run at a primary school to let them have the experience with a line tracing robot. So this is actually a Arduino programmed robot. And for those who don't know, Arduino is a programmable circuit board. So you can actually buy it on your own. It's not very expensive, I would say. And yeah, this is also to let them have experience with not only building the robot, but also coding and how the code can affect the behavior of a robot. On top of this, we also have a new style of workshop, which is aerodynamics workshop. So that exposes kids to aerodynamics principles, laminar flows, stuff like that, and also lets them have experience with aerodynamic car. So on to our events for NTU students, we have a few. One of them are talks. So this is a HR manager talk. We called it From the Horse's Mouth. And it was a talk that we organized during the beginning when COVID was getting really bad because there was a lot of uncertainty about hiring. And so we invited HR managers from, as you can see, Micron, Schaeffler, Bolloré Logistics. We got them to come down and share with students what they are looking for when hiring, what skills they prioritize now with what they like to call the new normal. And this actually was very well received. We not only had undergrads, we also had graduating students, we had even postgrad students coming for the event and finding out what HR is looking for in companies. Another is our leadership speech series. This recently happened. So this event is a series that we did for a few years, and it's basically to invite leaders from different engineering related organizations. So for this year's, we invited the CEO of Lionsport, which is a startup in Singapore, Mr. Justin Ang, our Director of Security and Resilience from MCI, and also Mr. Fabian Tator from Bolloré Logistics. So we invited them down to share their perspectives on leadership and skills in the working world. And this was also very well received. We ran it as a hybrid, and even our physical event, we had about 30 people coming down with the restriction of 50. Yeah. This is another photo of said event. And another event is actually the NTU HP Innovation Challenge. So this is not a talk, but it's more of a innovation challenge that we are running in collaboration with HP. So this is essentially what we like to call now a hackathon, and it challenges students to think about what is printing of the future like, and give a business proposal of how that new printing would look. So this is currently ongoing. We have 7 teams in the finals. Each team is about 3 to 4 people. So this is quite a big competition as well. And finally, we talked about all our events and all, but we also do bonding within our club. So we always just go out for meals, maybe hang out between lessons, and even give each other pointers for classes, because in university, sometimes you just don't understand the content, so you need some help. And our club is honestly quite bonded. We do help each other out a lot, whether with resources or just generally how to do homework. Yeah. And that's all I have. So if there are any questions, feel free to ask in chat. And if you're interested to find out more about LDP, here's our socials, our Instagram, and our LinkedIn. So just look these up if you're interested. And I think that's all for my sharing. Back to you, Eileen.
Thank you, Ziwei. Okay, so now let us get to Manfred's question, which came actually near the start of our presentation. So Manfred has a question on whether, what are the poly engineering courses that I can take and still enter this course? Does this mean that if I take things such as aerospace electronics or electronics in poly, can I still enter this course? Okay, so Manfred, I think I need you to let me know which poly and what course you are currently studying, and what is the course that you're looking to join, whether is it aerospace engineering or mechanical engineering. Now, actually at the Office of Admission website, under the Polytechnic tab, you can actually find this web page that will allow you to cross-check the eligibility of your diploma and the course that you would like to study. So sometimes if, let's say, because our institution, NTU, we work very closely with all 5 polytechnics and all the international schools, all the high schools as well. So we have actually worked out with them to know which courses are eligible for a direct entry year to, which courses are eligible to study our undergraduate degree program. So if you actually can input your institution and your current degree or program together with the course that you would like to enter, you will be able to see your eligibility. But since Manfred, we are here live, I can do a check for you, and I can get back to you on that. Now floating on to some of the questions from Slido. What are some industry partnerships other than Dyson and HP for aerospace engineers? Does any student want to contribute to this before I attempt this question? Ziwei, do you have anything? Okay, no. So maybe I can just add on a little bit for this particular student. So for aerospace engineers, we do have a Rolls-Royce lab downstairs. So I've noticed that our graduates do have exposure to take on modules in the Air Traffic Management Research Institute. That is a collaboration with CAAS. We also have a Rolls-Royce lab where we carry out research projects. So in 2019, before the pandemic, 2 of our MAE students across the whole NTU, not whole NTU, whole Singapore. So regardless of other engineering courses in NTU and outside NTU, there are only 8 graduate Rolls-Royce program. And out of these 8, 2 NTU MAE students managed to secure this graduate program. So I think it really shows, the relevance and the demand for our MAE students. So I hope that answered this particular student's question. Okay, so for 3D printing, are we taught to operate the robotics arm, for example, RRP robots? Maybe this question I would really need to direct to the students. Would either Ziwei or Elgin know how to answer this question?
Uh, I think this student is referring specifically to the concrete 3D printer arm. That I don't think we will have in the regular curriculum at least. I don't think we have had exposure to it. Of course, it's hard to say if we if you say for example you have a Eureka project or any other kind of research project, maybe you have an opportunity to get in contact with that. But from my personal experience in the regular curriculum, we unfortunately don't have an opportunity to operate that particular machine.
Yeah,
Of course, if you're
maybe.
interested in 3D printing, you can join LDP. We have 3D printers for you to play with if you're interested.
Thank you, Ziwei. So maybe just let me add on a little bit on the robotic arm. So if let's say you're interested to know how to operate the robotics arm, and if it's a bit more relevant to the robotics stream, actually, you know, the robotics club in MAE, they actually do quite a bit of um, um, uh, uh, um, courses and workshops just by LDP. So we do have a lot of very unique workshops that are always open for our students. So you can always stay tuned and take on these extra learning opportunities provided by the clubs. So the students, they actually find resources. So for example, if LDP club, they notice that their members actually, you know, are interested in a particular area, sometimes they actually do approach industry experts, they do get industry speakers to try and meet these needs. So, you know, why don't you, you know, join us? And if let's say you have an area of interest, you can actually, you know, even propose to the team and, you know, you can see if that's actually something that the club wants to work towards too. So, you know, when we mentioned about 3D printing, I can't help but, you know, want to ask Prof. Hortons this question. So Prof. Hortons, I understand that you actually created your own ceramic 3D printer. Is that right?
We are currently developing, so building from scratch our own 3D printers, indeed.
Could you share with us your experience and you know, your challenges and what made you, you know, want to create your own 3D printer instead of using one that's already out in the industry, if there's even one there?
So the idea is to implement other functionalities in the 3D printers that we don't have currently. And also the 3D printers that we have commercially, they work only with one formula or a selected set of formulas. So for example, you know, there are these polymeric filaments that you can feed on some, so they're called FDM printers. So if you want to work with this material, if you want to work with this printer, you have to purchase the filament that go with the printers. And so now what I'm interested in is in printing ceramics. So you cannot really have a filament, or at least we are looking at a printer that works from solutions or paste. And we want to add other tools to the printers. So a printer that is able to extrude this paste, that is able to dry this paste, so some kind of temperature control from the stage, the environment, also that has external fields like electric fields, magnetic fields, ultrasons, and these are not available in available printers at the moment.
Thank you, Prof. Hortons. It sounds like a very complex project, but you know, if you're interested to find out more, you can always, you know, Google Prof. Hortons research and see if you can find something on Google, or you can always contact her online and ask her more about her project if it's whatever's available. But talking about 3D printing, I think I would like to take this opportunity to share with everyone that next week on the 23rd and 26th of February, we have two physical lab tours. You know, each of these tours are going to be kept very, very, very small because of safe distancing measures. So the vacancies are very limited. But one of these visits, so each day we'll visit 2 different labs. And one of these lab visits includes the Singapore Center for 3D Printing, which is actually one of Asia's largest research facility for 3D printing. So I've been there myself, and I've been amazed by the many, many things that they've printed. So for example, in the video Prof. Horton shared earlier, the 3D printed toilets, it's on display. We also have bioprinted skin. So, you know, how can 3D printed skin impact, you know, our lives, you know. If you want to have a look at some of these parts that are already printed, you can take a look. And if you want to have a hands-on experience in trying some of the 3D printing, actually LDP Club, Ziwei and his team do actually conduct quite a bit of these 3D printing workshops. And actually in the previous years, you know, I had the joy to join them in this printing, and all participants actually enjoyed this experience. We do also have some of our 3D printed parts on Science Center on display. So Science Center right now, they have this maker's wall. So some of our projects are up there on the wall. Some of our projects are in their exhibitions. It's rotated in and out. So sometimes you will see them and sometimes you won't. So it's really a matter of luck. But you know, if you are available, do join us next week as we take you on a tour to the Singapore Center for 3D Printing. Now let me just get back to the Q&A segment. I've gone on a little bit too long. I think we can have time for another one question. For the questions with regards to, you know, JC and Poly students, I will get back to you after we end this talk, because we have students, they're online, they can help to address these. Kevin, I see a question as well on IB requirements. Let me check up on that and I'll reply to you on Slido. But are there any questions right now for Prof. Horton's Ziwei or Ziwei, you know? So if you want them to be answered live, if you want to tap on Prof. Horton's expertise, you know, feel free to you know, share with us your question. Manfred, let me just resend you the link one more time, because I can access it though. So I'm not sure why you're not able to access it. Okay, are there any more final questions for Prof. Hortons? Okay, maybe if there's no other questions, I do have a question for Prof. Hortons. It's more of my personal question, which I think actually some females may be wondering, but Prof. Hortons, what made you decide that, you know, engineering and, you know, this area of research you're doing, it's actually something that you want to pursue? How do you develop this interest, and what made you, you know, take the step towards, you know, delving much further into this industry and this field?
Yeah, thank you. That's a great question. I was excited, as many of you are probably, about like building things. It can be building a machine, but building a material. So I was really excited about it, about creating something, about understanding how it works. And along my journey in studying science, technology, and engineering, I found that also, as a, you know, a very shy introvert person that I am, learning all this provides a lot of confidence and opportunity along the journey, because you learn from facts, you learn how to present data, you learn how to construct your thoughts so that you are being more convincing as well. So that's also something that really pushed me forward at each step. That at each step of my journey, I was learning something that I was excited with, and I had the support from peers and lecturer that also could recognize the value of what we develop by structuring our thoughts and being able to show our results convincingly.
Thank you, Prof. Hortens. So maybe now I would like to just show everyone a web page on, if let's say you're interested to know a bit more on what our undergrad students have achieved over the years. Actually, on our website, you can find it from our MEE website banner under student achievement. So these are actually a list of all our different students, what they have achieved over the years. Earlier, I think, you saw the Prof. Horton showing you this design stream prototype made for the blind that was also done by our MEE students. And this was actually a competition where our students at that time could take part. So they actually collaborated with Korean students and they came up with this. So it's meant to actually help improve the society and help, the blind, assimilate better into the community. So if you're interested, just feel free to visit our MEE website. Our contact details are also there. So with that, I end today's session, and I thank you all for spending your Saturday afternoon with us. Thank you, Prof. Hortens, and thank you, Ziwei, for your insightful sharing.
Thank you very much.
Thank you.
Yeah, and that's all for today. Thank you, everyone.
Bye.